salt in a glacier. To do this, we have clean ice that we've melted and dirty ice that we have melted from the Taylor Glacier. Obviously you can see that the dirty ice has a lot of sediment mixed in with it, and the clean ice, it's clean. It doesn't have that much sediment. So what we're going to do today to see if there is salt in any of our ice samples is we're going to test two different things. We're going to test the pH with the pH meter, and we're going to test the conductivity with the conductivity meter. When we're doing this, we're going to take each one 3 times and record it into a data table, take the average, and we should be able to see if there's a difference in the salt levels between our dirty ice and our clean ice. For our first measurement that we're going to take is we're going to take the pH of our clean ice using a pH meter. How the pH meter works is that it has a probe, and we just stick the probe into our solution that we want to measure the pH of, and then we read the screen to see what it says. Alright, so let's do our first measurement of the clean ice for pH. So we take our probe and we stick it into our solution, and we look at the screen, we wait for it to settle down a little bit. So on our first measurement for clean ice, we're going to put 6.4. So on our data table, we're going to write 6.4. To make sure our measurements are accurate, we're going to do it a couple more times and record it. So we put it in solution. And once again, we get 6.4. And for our third clean ice measurement of pH, stick it in, and this time it is 6.5. So now we have our 3 measurements. Our first one was 6.4, our second one was 6.4, and our third one was 6.5. So now you can do the average on that one. For our next group of measurements, we're now going to look at the pH of our dirty ice using the same pH meter. Alright, let's start the pH of the dirty ice. So we stick the probe into the dirty ice, wait for it to settle down. So it leveled out at about 7.2. So our first was 7. Alright, now our second pH for the dirty ice. It's climbing. And this one is probably about 7.1. And our last pH of the dirty ice, go with 7.2 on this one. So 7.2. So we have a 7.2, a 7.1, and then another 7.2. So you guys take the average. For our next set of measurements is we're going to look at the conductivity of our ice samples. So the first one that we're going to do is our clean ice. And we have a new meter now, and it is called the conductivity meter. And we're going to be measuring in microsiemens. So for our first set of conductivity readings, we're going to take the conductivity of the clean ice. So I stick the probe in the clean ice. So we are going to put 36. So 36 microsiemens for the pH or the conductivity of the clean ice. Now for our second conductivity reading of the clean ice, and we get 19. Now for our last conductivity reading of the clean ice, and we're going to put 17 microsiemens. So you have Our final readings are 36, 19, and 17, so you take the average. For our last set of measurements, we're going to take the conductivity of the dirty ice. So we take our conductivity meter and we're going to gently stick it into the dirty ice sample. And we get a reading of 2,838. It's a big one. Now for our second conductivity of the dirty ice. And we're going to go with 2,780 on this one. And for our last dirty ice conductivity, and we'll go with 2,802. So our final conductivity for the dirty ice, we have 2,838, 2,780, and 2,802. Now you take the average. In our last experiment, we learned that dirty ice has a lot more salt in it than clean ice. So now our next question is how much more salt is in the dirty ice than in the clean ice? To do this, what we're going to do is we're going to first take the conductivity of the dirty ice. Once we have that measurement, we're going to take our clean ice beaker, place it on the balance, and we're going to take a measurement of how many grams that is. We're going to record that and then slowly add salt into the conductivity matches that of the dirty ice, and then record our final mass. Hopefully this will tell us then how much more salt is in the dirty ice than in the clean ice. So the first step is to take the conductivity of the dirty ice to see what we're shooting for. So we're going to shoot for around 2,777. So that's what number we'll shoot for. So the first step that we have to do after we take the conductivity is take the initial balance of our clean ice beaker. So we place the clean ice melt water on the balance, and we get 674 grams. So that goes under our initial mass. So we have our initial mass is 674 grams. The next step in our experiment is to slowly add sodium chloride, salt, to our clean ice solution until the conductivity meter reaches somewhere around 2,777. So we're going to slowly add this and stir. So now we're up to about 1,100, so I'll add a little bit more. And then stir it. So we're at about, we'll probably add just a touch more because it's really jumping around that number. And that should be good. Yeah, so we're jumping between 2,700 and 2,800, just jumped down a little bit. So that's probably going to be maybe a little bit more because we just dropped a bit. Dropped again, so a little more. Alright, and with this last stir, we should be just about there with our readings. Yep, we're about 2,800, and so with this precise measurement, and it's probably going to be pretty good. So the last step, now that we have added the salt to our beaker so that it equals the same conductivity as our dirty ice, is to measure the mass now of our clean ice with the added salt. So you place it on the balance, and we get 680.6. So you write that down. And it's pretty simple mass to find out what your mass of the salt is that you take the final mass, which is 680.6, and subtract the initial mass of the clean ice, which is 674 grams, and that will give us the mass of salt that's in there. So you do the math and answer the questions, and we will be all right.